Hello everyone, I am 1s&0s, Assistant Professor, Department of ECT, Puttur. Today, we'll see 8051 program to count a number of ones and zeros in a given number. Before going to the program, let's see the logic how we are going to find the number of ones and zeros in a given number. For that purpose, we will be using rotate instruction. As you can see here, there are basically 4 types of rotate instruction. First one, rotate accumulator content right, rotate left, the accumulator content, rotate right with carry, the here and rotate right with carry. The LSB bit will be copied to carry and the carry bit will be moved to the MSB. Next one is RLCA, which is rotate left with carry. Here the MSB bit will be moved to the carry and the carry bit will be moved to the LSB. So in order to find or in order to count the number of zeros and ones in a given number, we can use the instructions RRCA or RLC instructions. We'll move on to the programming. Say that we'll assume that the number is stored in the memory location 40H. So our intention is to find in 40H we have one number, and in that the number of ones as well as zeros present in that number we need to give a count. So here we'll assume that number of ones will be stored in R1 register and number of zeros will be stored in R0 register. Now, for example, if I consider number 0, 1, the number of ones in that given number is 1 and number of zeros in the given number is 7. So, first step, go to File, go to File, New, you have to select Assembler File, and once Assembler File is selected and now editor window will be open, we have to type the code. The code is already written. Go to debug. Once the code is written, go to debug and start. Here if any errors are there, it will be displayed or else you can proceed. Now in 40H I load the number, say 0, 1. In 0, 1 there are 7 zeros and 1. Once this is done, we'll execute the instructions, we'll execute the code. The first instruction is org4000H, which indicates the origin of the code, which is in the location 4000. Move A, 40H. Here that content, the data is stored in the memory location 40H, and from there the data should be read and placed in accumulator. So the content present in 40H memory location will be copied to accumulator. And observe here the first instruction is executed. Now accumulator is having 0, 1, which is nothing but the content of 40H. The next step is to decide how many rotations we require. Since accumulator is 8-bit number, you can store 8 bits of value. So we need to rotate the content of accumulator 8 times in order to calculate number of zeros and number of ones. So move R2, 08 is a count. I can observe here the R2 value has been changed to 0. Next step is RRCA, that is rotate right with carry the accumulator content. That is nothing but the content of accumulator will be rotated to right along with the carry of 1 bit position at each iteration. Now for example, if we have 1, accumulator content is 1, rotate right is nothing but LSB bit is 1, therefore it will be moved to the carry flag. LSB bit will be moved to the carry flag, so therefore carry will be set to 1. We'll go for execution, say F7. You can observe here after rotation the content of accumulator has turned 0, whereas carry will be equal to 1. That means 1 has been moved to the LSB bit, 1 has been moved to carry. It also indicates that the increment of 1 register, the 1 value whichever register we are going to press, that register should be incremented by 1. So jump carry, you are going to check whether carry is generated or not. If carry is generated, it means that we have transfer or single, that is 1. If carry is not generated, it indicates that we have transferred 0. So in this case, carry is equal to 1. It indicates there is a carry generated after rotation. So it jumps to the notation next. Increment R1. As I told you, R1 holds the number of 1s. So you can observe R1 has been changed to a value 1. Next is DJNZ. One iteration is complete. DJNZ, that is decrement and jump if not 0. The content of R2 will be decremented by 1 and it will check whether it is 0. If not 0, it will go back to the label up. F7. R2 is 7, so it's not 0. So it will go back to the label up, where again the rotate instruction will be executed. RRC F7. Okay, now the instruction has been executed. Now in this case there is no carry. It means that 0 has been moved to the carry flag. Therefore we have to increment the 0th register, that is R0 register. So jump no carry condition will not be satisfied. It will increment R0. You can observe here now 0, 1 is passed. Next, jump to the next location. DJNZ R2 decremented. Now it will be 6. So this instruction again it will be executed. So therefore this loop will be executed 8 times, and at the end of the loop R0 will contain number of zeros and R1 will contain number of 1s. You can observe here now R0 is equal to 0, 7, which is nothing but number of zeros. R1 is nothing but 0, 1, which is nothing but 0 number of 1s. The given number input test location was 0, 1. If you convert this into binary, the number of zeros will be 7, which is nothing but stored in R0, and number of 1s is 1, which is nothing but stored in R1. And the program is executed.